Hello, class, and welcome to Chapter 11, where we'll be talking about fossil fuels. Very interesting and important topic that we're covering this week. So we'll specifically talk about coal, oil, and natural gas. And we'll start with a little bit of the Deepwater Horizon oil spill. Happened in April of 2010. A huge explosion. British Petroleum was at fault, where 4 million barrels of crude oil leaked into the Gulf of Mexico. 11 oil rig workers were killed, and the costs and benefits of using fossil fuels as the energy source were really researched after this awful disaster. So, what is a fossil fuel? It's a combustible deposit in Earth's crust. It's composed of fossil remnants of prehistoric organisms, and it includes coal, oil, petroleum, and natural gas. Fossil fuels supply over 80% of energy used in North America, and it's a non-renewable resource, meaning that fossil fuels are created too slowly to actually replace the reserves that we are using. How are fossil fuels formed? Many years ago, when the climate was mild, there were vast swamps covered much of the land, and dead plant material would decay slowly in the swamp environment. Coal is kind of the combination of heat, pressure, and time, turning the plant material into a carbon-rich rock known as coal. Oil is the sediment deposited over microscopic plants, combining heat, pressure, and time, turning into them a hydrocarbon or oil. And then natural gas is the fossil fuel formed the same way as oil, but at temperatures higher than 100 degrees Celsius. So these are our three main fossil fuels: coal, oil, and natural gas. All are non-renewable, meaning that we are using them faster than they are being replaced. So fossil fuels, the carbon cycle, and climate. So the burning of fossil fuels releases carbon as carbon dioxide, carbon from plants that first fixed it via photosynthesis, but increasing the export of carbon dioxide to the atmosphere, but not actually increasing fixation. The natural cycle then is changing really slowly, and burning is the quick change. So we're completely out of balance because we're burning up too much before we're replacing it. Most, if not all, coal deposits have been identified, and coal occurs in different grades based on variations in heat and pressure during burial. And these grades are based on energy density or energy per volume. We can have types of coal, the color, the water content, the relative sulfur content, carbon content, and the average heat value, and then cost at the mine for 2,000 pounds of coal. So we see the blackish coal would have the largest average heat value and be the most expensive. Coal is highly flammable. It's dangerous to mine. Burning and mining releases pollutants. Over 90,000 miner deaths occurred during the 20th century. Miners have an increased risk of lung disease and cancer, and 2,000 miners actually die each year from those diseases. The United States has 25% of the world's coal supplies, and the known coal deposits could last as much as 200 years at the present rate of consumption. So that's why there's some thinking into the proved recoverable coal reserves as of 2013, Asia and Oceania, which includes Australia. Lots of coal in Australia, lots of mines there. Eastern Europe and Russia, North America, Western Europe, a little bit in Africa, and in Central and South America. So coal is usually found in seams that vary from 1 inch to 100 meters in thickness. Surface mining is shown below, and that's usually chosen if coal is within 30 meters of the surface. An example of that is strip mining. And then subsurface mining occurs when the extraction of the mineral and energy resources are from very deep underground deposits. There was a Surface Mining Control and Reclamation Act as of 1977, which requires filling or reclaiming of the surface mines after mining, and this will reduce acid mine drainage, and this requires permits and inspection. Prohibit coal mining in sensitive areas, and land with mines abandoned prior to 1977 are slowly now being restored. Acid mine drainage. This is pollution caused when sulfuric acid and dissolved materials like lead, arsenic, and cadmium from coal and metal mines will be put into nearby lakes and streams. Rainwater seeps into these exposed mine wastes, and this contaminates soils. So the topography before mining, we see the coal, 4 feet coal seams, overburden dumped into the valley, coal removed. Let's start with number 1, actually. A blast hole is drilled, explosives are planted, the blast hole fractures the overburden removes the drag line, the overburden is dumped into the valley, and then coal is removed. Topography then after mining, you can see the original contour of the mountain and how it has changed, and the valley is filled with that overburden actually blocking the stream. So we've actually removed parts of the mountaintop. Environmental impacts of burning coal: it releases large quantities of carbon dioxide into the atmosphere, which can lend to greenhouse gases, and other pollutants can also be released: mercury, sulfur oxides, nitrogen oxides, and this can cause acid precipitation, which is rainwater, can be acidic, about 5.6 pH, and acid rain, which is very acidic, about 2.1. Scrubbers is a desulfurization system which removes about 98 to 99% of sulfur from the power plant's exhaust. It's really expensive, and sludge can be a byproduct which has to be disposed of. Sludge and fly ash are part of resource recovery. They can be a marketable product from wastes, but the nationwide cap of sulfur dioxide and nitrogen oxide emissions needs a cap. Fluidized bed combustion. This is crushed coal mixed with limestone to neutralize acidic sulfur. The EPA, the Environmental Protective Agency, can regulate carbon dioxide emissions. This was made from a 2014 Supreme Court decision, and there's a little bit of controversy because carbon dioxide is also a natural product of respiration and organisms. But there's a push for carbon capture and storage, where new power plants will store carbon dioxide when released. It's initially expensive to install the technology, and there's a little bit worry about where and how to store that captured CO2. Oil and natural gas were extremely important after the 1930s, making it more versatile and easier to transport and cleaner to burn. Oil and gas, as of 2013, provide about 62% of U.S. energy, and they provide about 58% of overall the world's energy. This is how petroleum is refined. Numerous hydrocarbons are present in crude oil or petroleum that are separated based on the boiling point. Natural gas contains far fewer hydrocarbons than crude oil, like methane, ethane, propane, and butane. Natural gas contains methane, propane, and butane. The propane and butane are used for cooking and heating in rural areas. The methane is used for heat and to generate electricity in power plants. Natural gas as a vehicle fuel, it emits about 93% fewer hydrocarbons, 90% less carbon monoxide, and 90% fewer toxic emissions than gasoline. Natural gas was first compressed into liquefied natural gas, as shown here, using these ships to kind of help do that, and then storage tanks. Oil and natural gas migrate upwards until they hit impermeable rock, usually located in structural traps and the underground geological structure. Present. Oil reserves are unevenly distributed globally. More than half is actually located in the Middle East, as you can see there. Natural gas reserves also unevenly distributed. More than half is actually located in Russia and Iran, and European energy concerns with Russian takeover of Crimea, another country, in 2014. And as we know now, there's even more things going on with that. How long will the supplies last? So it depends on locating more deposits, future extraction technologies, changes in global consumption rates, and experts indicate there may be shortages in the 21st century. The Marcellus Shale is a huge store of natural gas in the United States. It's beneath more than 24 states, and shale gas is more difficult to extract than in sandstone because it requires fracturing of rock via hydraulic fracturing. Hydraulic fracturing is when water and chemicals are pushed at a very high pressure to crack the rock, releasing the trapped gas, and this produces large amounts of wastewater. It's controversial because regulations are very slow and the environmental impacts are variable, and we don't know a lot about it yet. Wastewater is stored deep underground and it could cause earthquakes if injected incorrectly. So hydraulic fracturing is drilling a rig 6,000 feet down, creating fractures in the rock and then allowing that oil to bubble up to the surface. Environmental impacts of oil and natural gas combustion, an increased amount of carbon dioxide and pollutant emissions. Natural gas is far cleaner burning than oil. Production could disturb, land and habitat, and then transport. We could have different spills, especially in the aquatic systems, like in the Alaskan oil spill in 1989. The Deepwater Horizon oil spill occurred in April 22nd of 2010. It happened in the Deepwater Horizon. A drilling platform in the Gulf of Mexico exploded. The flow of oil from the oil well was finally stopped in mid-July, several months later. 5 million barrels of oil flowed into the ocean, and most rose to the surface, where it spread nearly 75,000 kilometers of ocean. So this is a look at that Deepwater Horizon spill. The British Petroleum still in court about reparations from that January 15th, and payments to those are affected by the oil spill. 1989, the Alaskan oil spill, with Exxon hitting a reef and spilling about 260,000 barrels of crude oil, the largest oil spill in U.S. history, and it led to the Oil Pollution Act of 1990. And there we see the Alaskan oil spill, 1989. So case in point, the Arctic National Wildlife Refuge, this controversy is more open to this. Now, there's many stakeholders: Alaskan natives, energy corporations, politicians, citizens, gas prices, and domestic energy reliance. Synfuels is a liquid or gaseous fuel that is synthesized from coal and other naturally occurring sources. It's a substitute for oil and natural gas. The tar sands make bitumen difficult to remove. They must heat it underground. Energy. The Keystone Pipe debate will run through the U.S. from tar sands in Canada, and oil shales are the crushed and heated to yield oil. And this is how synfuels are created: ice-encrusted natural gas deep under the permafrost in the Arctic, then liquefied to coal, and then the coal gas burns as cleanly as natural gas. Environmental impacts of synfuels: many of the same undesirable effects as the fossil fuels, contributing to air pollution, global warming. The coal gas requires large amounts of water to extract, mostly located in areas very short on water, and recovering fuels in the tar sands and oil shales would require extensive surface mining, very environmental, dirty, and more CO2 during production than other fuels. Thank you for listening to Chapter 11, and we'll see you for the next chapter.